Scott's computer. There we go. Looks like a small crew. People will probably be joining us for a few minutes here.
I couldn't really read to page 99 because I was helping my family get ready for Christmas.
You got to what? I'm sorry?
I couldn't read to page 199.
Because you were getting your family ready? Well,
yeah,
okay, well, hopefully you got close because you're supposed to be reading every day. And I will tell you this, I've been giving kids their reading tests and I'm super impressed. Kids are doing really well. Most people are telling me it's because they're reading more. So nice job. The more you read, the better you do. All right, everybody's coming in now. It is Monday, December 5th. And we are to our last lesson of Module 6 on force and motion. And it's kind of a fun one. It is, usually I've been giving you like 2 or 3 days for these lessons, but I looked at this one and it's a pretty simple concept with a quiz at the end. So I think we can do it in a day. Let's see your nails, Nora, if we need to see your nails. Oh my gosh, are those real?
No.
Very fancy. All right, friends. So today's lesson is 6.07 on force and motion. And we're going to go through it together. So if you open up your Canvas right now, you'll be able to kind of follow along. I will share my screen and we're going to kind of go through the lesson and then it has a quiz at the end and I'll let you go do that with your friends if you'd like to. I've also got 2 little videos on this that are kind of fun. So there are 14 pages. The gist of today is that we're talking about balanced and unbalanced forces. So we're going to investigate and explain that when a force is applied to an object, but it does not move, it is because there is another opposing force being applied by something in the environment, so the forces are balanced. When you apply force to an object and it does move, that's because there's not an equal and balanced force on the object. So we're going to talk about that. And then the second thing they want to talk about is how if you're making a scientific observation and investigation, you need to base it on actual evidence and facts, which is kind of what we're talking about in reading, making sure you have facts and evidence. Page 2, types of forces. There's friction. Friction is when you rub your hands together, they get warm, and that's the energy caused by them actually rubbing against each other. Nowadays, they create all sorts of things that make friction more or less so that you'll have less force applied to something or more force, depending on what you want it for. Back to the types of force. And then you have push or force, all right? Let's learn about balanced and unbalanced force. So at my house, at least, we've been watching a lot of soccer and football. When the guys all push against each other equally and they don't really move, they're sitting there, that's balanced force because there's an equal force on one side and the other. But when they bash into the guy and he falls over, that would be an unbalanced force, causing a change in motion. It says, put your hands together. Everybody put your hands together right now. If you push equally, your hands stay in the middle. But now let one hand push harder than the other and see what happens. Aha, that's an unbalanced force, right? You could share your observations and say, when I push harder with my right hand than my left hand, my hands move to the left. How many of you have ever done tug of war with a rope? Anybody? Yeah. So in tug of war, if you have equal forces, the rope will stay right where it is and nobody will move. But as soon as you have more force on one side pulling than the other side, then the whole crowd, like over here, if there are 4 people and they're stronger, these guys are going to fall over and the rope's going to go that way. When there is a rope on each side of the sailboat, it's going to stay in the middle. If there's only force applied to one side and there's not an opposing force, then it's going to change motion. Here are some force diagrams. So in the 1600s, Sir Isaac Newton first proposed that there's a force called gravity, and we're going to watch a little video about that. The story goes that he thought of this when an apple fell on his head. Now we measure the amount of force on an object in units called newtons. They're named after him, aren't they? Gravity is a force that pulls 2 objects with mass toward each other. On Earth, it pulls objects toward the center of the Earth. In order to lift something like a heavy bucket in this image, you'd have to apply a force that's more than the force of gravity. So let's look at this little video on Sir Isaac Newton and see what they're talking about.
Have you ever wondered why our planets keep spinning around our sun? How come the planets don't spin themselves out of orbit? What is keeping them in place? And what is keeping us from floating off into space? The answer to these questions. He wanted to know what was keeping our planets in orbit. So for about 10 years in the late 1600s, he observed and studied the planets. What he came up with was his law of universal gravitation that explains the attraction or force that exists between any two masses or objects. This is the force that we commonly call gravity. But did you know that this force is present between any two bodies? That's right. You yourself are exerting a force of attraction on everything around you.
Oh,
So why aren't things being pulled towards you? Because the Earth is much larger. It exerts an even larger force of attraction that pulls on things with greater force than you. In a sense, the Earth wins when it comes to attracting things to it. In a sense, the Earth wins when it comes to attracting things to it.
said that twice.
You can't beat the Earth. This is the force that Sir Isaac Newton created a formula for. So today,
I can't see it because it keeps
I know, it keeps
between
doing
two
that.
objects. We can use this formula to see how much greater the force of gravity is between a basketball and the Earth, and between the basketball and us, to see who wins. What is this formula? The formula is F equals G times M sub 1 times M sub 2 over R squared, where F is the force of attraction between the two bodies. G is the universal gravitational constant.
Can't give it
M
to
sub
her.
1 is the mass of the first object. M sub 2 is the mass of the second object. And R is the distance between the centers of each object. Notice how I've used the word mass instead of weight. This is because mass is different from weight. You see, your weight is dependent on the amount of gravity that is pulling you down. That is why, in space, you are weightless. Your weight now is different, but your mass stays the same, no matter how much gravity is pulling you down. Your mass tells you how much stuff you're made of. No matter where you are, the amount of stuff that you're made of stays the same, and that is your mass.
Okay, I cannot get my stupid thing back. My cursor is stuck on the big screen again. Sorry, you guys. This has been a nightmare today. It's kind of a cool screensaver though, isn't it? Do you guys see my weird screensaver? Okay.
Yeah.
What in the world? I can't get it to come back. Come on. Ah, come on, you dumb thing. What am I?
How did you get stuck onto the big?
Well, I have two monitors and it keeps, oh, I bet if I unplug, I'll unplug the monitor. There we go. Now I bet it'll be back here.
Wait, now why are you on Firefox now?
Am I on Firefox now? Okay, I'm going to stop my share. Okay. All right. Sorry about that. That was terrible, the way it kept switching. I don't know why I'm on Firefox now because it keeps getting stuck on the big screen. I'm not going to use that anymore. All right. So back to our lesson. Let's go back to our lesson. So we learned about Isaac Newton and we learned about the force that is exerted on an object from gravity. And we learned that we ourselves have got an attraction. We actually are pulling things to us. And if we weren't on Earth, where we have so much gravity to oppose, and it wasn't balanced, things would actually might come and stick to us, which is kind of amazing. I wonder if that ever happens out in space. So in order to understand this better, it helps to draw a diagram showing the force on the bucket up and the force below. So in the force, if the force of gravity is 100 newtons and you pull upwards with a force of 100 newtons, the forces are balanced. The bucket won't move. If you want to lift the bucket, you'll have to pull with more than 100 newtons to create an unbalanced force. So it depends. There's not like just one strength of gravity. It depends on how big the object is and how close together. Here's another example of a force, balanced and imbalanced. If we were together right now, we could try a little arm wrestling and see if we have a balanced force or an unbalanced force. We could try Zoom arm wrestling, but it's a lot easier, I think. You could arm wrestle with yourself. Do you think that that would be balanced? All right. Here's an example of a balanced force. She's pushing down on the log, but the log has enough strength that it's pushing up and holding her up. Again, if you look at this vase sitting on an object, there is weight or gravity pulling down on the vase, but the stand has strength pushing up, so it's balanced. Here we have a force pushing up. Is there anything pushing against it enough to stop it from moving, or is it moving?
I think it's moving.
It's moving, so it's an unbalanced force because there's not enough gravity to hold that rocket down. It's taking off.
Yeah.
An example of an unbalanced force because the rocket is moving. Here you see a little girl sitting on the couch. This couch is strong enough that it's an opposing force equal to the gravity, and so she's being held up. If you sat on a piece of paper, it would probably fall down.
Yeah, I am also
Sitting on a balanced force right now.
I'm
So
sitting.
we're looking at these to see if it's balanced or unbalanced. There are 3 people right here. They're both leaning in and nobody's falling over. So that looks pretty balanced. But here they're jumping in the air and they're able to move. So it's unbalanced. They're using enough force to break through gravity. Then they have a bunch of examples of which is balanced and which is unbalanced. In the end, unbalanced forces are the ones where something moves, like using a seesaw, although honestly, they're kind of balanced with each other. Jumping on a trampoline, a kid is going up. Holding a guitar is pretty balanced. It's just sitting there. In this case, the floating is balanced, but the boat moving forward is imbalanced. So it's kind of hard to say what.
But it's just floating. It's just floating. So
I know it doesn't say sailing, it says floating. So I think it goes here. These are equal and these are unequal. Okay, submit. Correct. We got it all right. Page 7. Have you ever given your friend a high five? As your 2 hands come together in a slap, the forces become balanced. But has your friend ever hit you too hard? Yes. And then it's like, wow, and it's unbalanced. A high five should be a balanced force.
I got slapped in the face because of it.
Ugh, that's not good. In the next activity, you're going to investigate balanced forces and unbalanced forces in your home. Now, I will say this experiment to me is a little bit lame, and you don't have to submit it. So I'm just going to go through it really quickly. It says find some heavy objects and check with an adult. Make sure it's safe to push it. Push the object. So here's a table. Let me push it.
No.
It's not moving. I guess it's balanced.
That's also too heavy.
Why do some objects not move? So why do you think it didn't move? You said the weight, so the gravity pulling down on it is too great a force and I can't apply enough pressure to move it.
Yeah.
It's also got friction where the feet are touching the ground. Measure how far it moved. Well, mine didn't move at all. Find a light object and try to push it. Okay. Why did it move? Well, it didn't have
a lot of weight. It didn't have
the gravitational pull, right? And I'm supposed to make a chart of it, which is, kind of fun. You can do it if you want to, and talk about balanced and unbalanced forces. Not too exciting. You don't have to do that experiment unless you want to. You can push something around in your room. Scientists recognize the importance of using evidence to support their conclusion. Statements supported by evidence are more trustworthy. Before you write a conclusion, let's discuss the type of evidence you can use. You can use observations. That's when you look at something and you actually see it with your eyes. It's not what you think happened, it's what you actually saw happen. Okay. You can use results. Data is often displayed in charts or graphs, or statistics. Those are results, and you could use that data. Okay. The final thing you can use is scientific research. This is where somebody else has used observations and data to form some conclusions, but you feel that the conclusions have been backed up by enough evidence. So articles, books, encyclopedias, and reliable websites are examples of places you can find your scientific research. Did you include any research in your conclusion? So those are 3 pieces of evidence or types of evidence to support a scientific conclusion: observations, results or data, and scientific research. Self-check. What is the difference between an experiment and an investigation? An investigation has a variable that changes. That's an experiment, isn't it? An
Yeah.
investigation is when you combine two chemicals, not necessarily. An experiment is when you build something, not necessarily. An experiment uses controlled conditions to answer a scientific question. Ah, that's it. Excellent work. Okay. Find the correct word for each of the blanks. Scientists know that it's important to use what? Books, conclusions,
Evidence.
evidence to support their
Conclusions.
conclusions. A scientist explains the observations they made in an,
Experiment.
yeah, to help other people understand what happened. Scientists then
Organize.
their observations and results into graphs called, let somebody else answer. Are the graphs called books or data?
Data.
Thank you. They also use scientific research from articles
Books.
and encyclopedias to support their conclusions.
I mean, books would have been the last one.
I know they only gave you one choice. Forces create balance. Through your investigation, you've identified that when a force is applied to an object, but the object does not move, it is because another opposing force is being applied by something in the environment. Think of a following example involving gravity. If you're trying to lift a large stack of newspapers and it isn't moving, you know that's because of gravity. Gravity is applying so much force in the opposing direction that you can't apply enough force to lift it. If you can lift it, then it's balanced. And if you can lift it far, then it's unbalanced. When you're carrying groceries, are the forces acting on the bag balanced or unbalanced?
It looks balanced.
They're balanced until you drop it. Again, balanced. Page 11, evidence supports explanation. Balanced force means no change in the motion. If there's a change, it's unbalanced.
Yeah.
How do you think the mass of an object affects its motion when there's an unbalanced force applied to it? And again, we did an experiment with this last time and with our, what do you call them?
Rocket.
No, when we made the
Oh, wait, the clay balls, the catapults.
yes, the catapults. We realized that if there's more mass, it's going to take more force to move it, right? After reading the article, answer the following questions to show what you have learned. Using what you've learned from the article. Where's the article? Is this the article?
Yeah, this is the article.
Got the whole thing?
That's the whole thing.
Well, it's not very long. Which object will have the greatest change in motion if the same force is applied to it? A soccer ball, a golf ball, a beach ball, or a pool ball? I presume the beach ball is a blow-up ball. I don't know. Which one has the least? Oh, here we go. Which one has the least mass?
The beach ball.
Okay, then I think it's going to be the beach ball. Let's see. Well done. Next. Complete the sentence. I can use blank to support my scientific understanding. Any book, a friend's opinion, appropriate reference material, or cartoons.
Obviously, cartoons.
Cartoons.
Obviously, cartoons.
See what I mean about this lesson was pretty easy. After reading the article, if you apply the same force to each of the balls, how could you present the data to help you interpret and analyze it? Could you do it in a prototype, a graph and table, a graphic organizer, or pictures and comics?
Graph and tables.
Silly, isn't it?
Yeah.
Oh, finally, you're to the quiz. So this is the quiz. It's worth 20 points. It's quiz number 6.06, and you need to submit it today. So you may work with a partner in a breakout room. You may work alone in a breakout room, or you may work on your own off of the Zoom. But that's all we have left to do for today. You should get that submitted. It's pretty easy. I will tell you what, I'll let you guys choose your own rooms. There you go.
Me and Eli were actually starting the quiz, so.
Okay. Well, why don't you guys head to a room like room 2? Liam, why don't you and Eli go to room 2? Oh, Eli's already in room 1, so go to room 1, Liam. There you go. If you guys want to work with somebody, go to the same room as somebody else. Oh, that's a lot of people in one room. I better go see what's going on there.
For the book.
Hey guys,
Book
too
club.
many people in this room.
This
So-
is for the book club.
The first two people can be in the room and the rest of you need to go. So Eli, Liam, were you working on this already?
Yeah.
Okay, Amadi, you can stay with them if you want to, because it looks like they all left. And then I'll pull you guys in here for book club in a little bit.
Oh.